What's up, guys? So this is Chris with Croft CNC. I want to show you guys how I'm going to prepare this thankful sign for a production run. So a couple things that we have to do first is I have to get my offset of what I want. So I'm making this on a 12-inch wide by 5.5 inch tall by 1 inch thick white poplar board. So I have my material set there. I do a 12 by 5.5 rectangle. I'm going to offset that inwards by a 1/2 inch. Let's actually do that by a 1/4 inch. Alright, so now we're offset by a 1/4 inch in, and I want to offset that one more time by, let's say, a 1/4 inch in. So we'll select that one. There's that. Now, you know what? I don't want to do that by a 1/4. I'm going to do that by 30 thousandths. Let's go 2.8 or 0.28 offset. Okay, we can delete that. Now this will be a channel that we mill out around the thankful. Now let's offset that by a 1/2 inch. Let's see what we end up with. Okay. Get that in there. Let's shrink this up a little bit. Let's bring this down a little bit. Okay. So now I'll have this channel here, and I'll have the words. I don't like that. All right. We're going to be using a 1/16 inch bit to clear all this out. If I did that, that would take a lot through here. So what I'll do is I will offset that 0.06064 offset. Okay, there's that. Now we'll offset that by 0.5. Okay, that's going to bring that out that way. Let's bring it out that way. Let's bring it down. Let's bring it up. Okay, that's going to be my design. So for right now, I'm going to save this, and I'm actually going to export mine as a DXF, and the reason being, I know that I'm faster with another software to do this, so I utilize the tools that I have. You guys can do the same thing in VCarve, and you'll have to play around with it, but you'll get the idea of what I'm doing. So I exported this. Now I want to use B for brush, and that brings up a circular dot, and I'm actually going to go 0.0625, and I'm going to go around and see where this material might hit the end mill, and everything looks good for the T. We'll zoom in here. Okay, the H, that looks good. The A looks good. Okay, that's good. Okay, right in here, that looks good. That looks good. Right through here, that looks good. Alright, good. Good. Golden there. Golden there. Alright, what I'm seeing is so far so good. Alright, with everything going, I shouldn't have a problem with any of it. So I checked everything checked out. We'll go back into Thankful. Now, a lot of people will just select. I do not. I want to pocket this. So I will go in there. I want that pocket to be and a little under an eighth down. We're going to select our flute. Or not our flute, our end mill. I'll have to change that out at the machine. So I'm selecting that just because it's going to take 17 passes for that. It's only 6 thousandths past depth. 40% step over. We could up that to 80%. And we could up our pass depth to 9 thousandths. And that takes us down to 12 passes. Okay. Could probably take that a little bit stronger. Pretty sure my machine can handle it. Actually, we'll take it back down to 0.6. 25. $1,600 feed rate, and I use the Millwright CNC app to get a good feed and plunge rate going. Cutter number of flutes is going to be 2. I go pretty aggressive. Okay. All right. Looks like we can go. Let me get a pen here. So our feed rate is 981.4560 millimeters per minute. Our plunge rate is, or our depth of cut is 1.3543 millimeters. We go to the converter. We type in 981.456. That's 38.64 inches a minute. And then our plunge is 1.3543. That's 0.0533. All right, let's up this to 38.65. Let's make it 39, and then a tenth of that will be 0.39. Right? Let's go to the calculator. Let's do 39 times 0.01. Or is it 0.1? It's 0.1. See, I'm already messing up. .9 inches a minute. See, that's why it didn't look right. Okay, step over 80% diameter. So that's going to take 2 passes. There we go. Now we're looking good. Okay. All right, we will conventional, roster, or offset. Do that. We'll ramp our plunge move. All right. calculate this bad boy and see what we come up with. I'm not sure why there are deviations in that. Okay, it's just the graphics. Okay. Now we can go back here. We'll select all this. Something I want to do here. I want to move this down a little. Alright. Now we'll go in and we'll clip this. Okay. We'll exit out of that. Now we'll go to Validator. Okay, we're able to close that. Now we'll go to Convert Curves. Okay, we took care of a lot of our extra node points that we didn't need. Now we can create our pocketing toolpath. Okay, that's what we're going to end up with. Let's move that slider back, reset the preview, and see what we're coming up with. And how we can speed this up. So this is really a not real fun part of the process, but it's a necessity. Okay. Now the reason why I didn't just go with a multi-tool setup is because I'm going to have a new shop helper running the machine tomorrow, and I'm actually not going to be here, so I want to make sure that this is going to be easy enough for him to run that he won't need me. I can show him once and be done and out. Okay. That's all looking really good so far. I don't know why it's going all the way over there. That's one of the things I don't like about VCarve is its toolpaths don't make any sense. But then again, that's just because I'm used to being able to choose my tool path in the way that I want. It's looking pretty good. Not too many useless moves. Okay. Looks pretty good. Let's go up here and see what our summary is. 5 minutes. So that's going to take an hour. I can speed that up. That actually might change a little bit. Yeah, that's about where we're at. Like I said, I think I can play around with that a little bit and get this thing rocking and rolling a little bit faster. Maybe we could do a 2 tool setup, run all of them, the large one first and then the not so large one next, and speed that up a little bit more. So that's basically how we're going to do this for right now. So we'll generate our G code. We'll save that as thankful pocket .0625 end mill. And mill to flute. Alright, we'll close that down. We've got our thankful. We'll now go into NC viewer. Now we'll open, get that. Let's see what we've got here. Okay. All right. Now, what I'm looking for, what I'm seeing here, those are my ramp moves to ramp down. Why it's going all the way up, that's what I want to know. Okay, so it's ramping in. Okay, now we'll go down here and we'll set each one of these. Okay, it's off to the races there. It's not making any upward okay. Okay. All right, there we go. Okay, why did we go up there? I don't want to go up. Okay. Now, I want to figure out why that's going up. Okay. Do we need that motion up? I would say no, we don't. So I'm going to backspace and see what we have here. So yeah, that looks like a useless move. Okay, there's my 0.2813, 0.2813. Then it goes a Z up movement. Okay, so it's our X, our Y, Y. Okay, this is down. So we're down 0.05. And then it wants to come up to 2, go over, and go to 0, and then go down, go down, go down, go down, all the way down to 12. Okay. Okay, so those are my ramp downs. All that's just ridiculous. But I see what it's doing. Okay, I know what it's doing now. All right. Now we can start seeing what it's doing here as far as its movements. All right. It's not doing a lot of up and down motion. Okay. All right, so we'll open this back up. Now let's see if we can take any time off of this by using a clearance tool first. and seeing what we got. Okay. So we'll hit that. That comes up. Let's use the upcut 71. We'll do an OK. It's going to do that in one pass. Offset it, conventional, ramp my plunge moves. Let's calculate this. Okay. We're going to move this up. Okay. Reset my preview window. Now we're going to come in with an 1/8 inch bit. Clean that. Now we've got our 16th bit. Okay. Okay. Let us now Alright. So we can delete this. We can now go in here, use a larger tool. We know that that's going to take 5 minutes to do. Okay. Let's recalculate that. Let's move this pocket clear. Okay. Reset the preview. Preview all tool paths. Okay. Okay, now let's go to that. Okay, now that took us down. That's 6 minutes there. So that took us down to less than 24 minutes. Well, a little over 24 minutes. So 20, 25, 26, 26, 13. So 26 minutes and 13 seconds. Okay, and I have a feeling that that's going to be a little bit faster, especially because I haven't saved any of my tooling from out at the machine to my design computer, so a lot of my times aren't right. So now we can close that. We can save this file, and I am done and can go out to my computer out at the machine. So have a good night, guys, and I'll see you later.